Okay, students, Chem 30, Lesson 4, Aromatics. Let's take a look. Basically the same goals that we've had for a few lessons now. We'll talk about organic compounds in daily life. We're going to name and draw structural, condensed structural, and line diagrams according to IUPAC rules. Today we're talking about aromatics. Alright, so what's an aromatic? Well, if you look at this chart that I've created, you'll see it basically has two divisions: aliphatics, aromatics. And so we can have either the aromatics, which contain this structure here, which is called benzene, or you can have aliphatics, which contain hydrocarbons and hydrocarbon derivatives. We haven't talked about those yet. But with the hydrocarbons, we have talked about these: alkanes, alkenes, and alkynes, single, double, and triple bonds. Okay, so aromatics are organic molecules that contain the benzene functional group. So just like this is a functional group, that double bond identifies it as an alkene, that structure there, benzene, identifies these compounds as aromatic. So remember, we've got aromatics or we've got aliphatics. Now these are called aromatics because they have distinctive odors, some of them. So for example, here is vanilla. There's the vanilla plants. Now you'll notice I've got this shape right here. That's benzene, and I've got some other things coming off. But because I have this, that's an aromatic. And we all know that vanilla has a particular aroma. There's what this diagram looks like, and you're also going to see a diagram that looks like this occasionally. So this and this are synonymous, and I'll talk about that in just a second. Okay, so benzene has a formula of C6H6. So watch carefully. Here's benzene. There's that diagram I just showed you. Now if I was to use the ball and stick model, here's what this diagram is. We've got 6 carbons attached to 6 hydrogens. Okay, and so the formula is C6H6, as opposed to cyclohexane, which would look like this. So in both of these we have hexagons. 1, 2, 3, 4, 5, 6. There's a hexagon. You can see the 6 black carbons there. But off of each one of these carbons is 2 hydrogens as opposed to 1. So you count all that up and you get C6H12. Now remember, because each carbon has 4 bonding electrons, each carbon should have 4 dashes. So there's a carbon. 1, 2, 3, 4. Here's a carbon. 1, 2, 3, 4. Now look over here. I've got 1, 2, 3. Where's the 4th bond? Well, that's what this circle in the middle is. This circle in the middle represents the 4th bond. And I'll get into that a little deeper in a second here. Benzene is not an alkene with a double bond. We'll talk about that in just one second. Early theories thought its structure was made up of alternating double and single bonds between the C's. So single bond, double bond, single bond, double bond, single bond, double bond. Okay, so it could either look like this or like this, or I guess I could show it like this. Okay. Alright, now I'll go back here. Scientific evidence suggests that all the carbon-carbon bonds are equal in length and strength. So the evidence is telling us when we do tests. So there's a test for double bonds, and I'll go into that test I think in another lesson, but basically we drop drops of bromine in here into a pool of benzene, and we think we would get an indication that double bonds are present, but we don't. We get the indication that it's all single bonds. So instead of having this diagram, we have this diagram. So here's my carbon, 1, 2, 3, and this circle represents the 4th bond, which basically is the thinking that these electrons are shared between all these carbons. So we don't need to go too much deeper into that in our course, just know that benzene is not an alkene. There is no evidence of double bonds in benzene. Okay. Oh, and you will see this diagram on the test. So this, or I should say, you may see this diagram on the test. If you see this diagram, you certainly know we have benzene and we're dealing with an aromatic. If you see this diagram and an arrow and this diagram, that represents this. And our program of studies tells us we might see this diagram on the test. Okay, so here's our structural diagram, a condensed and a line. Okay, let's name aromatics. The benzene functional group can either be a parent or a branch. Let's deal with it as a parent right now. Okay, now how do we name and draw these? It's just like with cyclic hydrocarbons, and we'll use that pattern number dash branch parent. Okay, so let's talk about having one branch. So let's take a look here. We've got a parent, we've got a branch. Let's say you just used all the rules you already know. What would you name that? Okay, well you might be thinking, okay, this branch will be named before the parent, so this is a methyl, and this is benzene, and this branch is attached to carbon number 1. 1-methylbenzene. And you'd be right. Now because this branch could be attached anywhere, but no matter where you attached it, you'd number it number 1 because there's only one branch. You don't need the number 1. Methylbenzene. Alright, what would you name this one? You probably already have it. That is an ethylbenzene. Got my ethyl and a benzene. What would you name this one? Now be careful, here's a carbon. Coming off that carbon is 1, 2, 3. This is a branch of 3. Propylbenzene. Good. Okay, let's keep going. What if benzene has 2 branches? Okay, now numbers are going to matter because I could have my branch here and here, or it could have been here and here, or here and here. Now numbers are going to matter. Okay, give that one a try. What would you name that? Okay, we'll have to go 1, 2, or we could have gone 1, 2 the other way. It's going to come out the same. 1, 2 dash di, don't forget that prefix, dimethylbenzene. Great. What would you name that one? Well, there's a propyl, there's an ethyl, so let's go alphabetically. 1, 1-ethyl dash 3 dash propylbenzene. Okay, what would you do with this one? That's a methyl, that's a propyl. 1-methyl 4-propylbenzene. Great. Okay, now let's go to 3 branches. Alright, so we could name our branches. We have ethyl, we have methyl, we have propyl. Now let's just name it alphabetically. And so, because we have an even spread here, we've got branch space, branch space, branch space. We can number it this way. Okay, and so I've got 1, 3, and 5. 1-ethyl, 3-methyl, 5-propylbenzene. Great. Okay, this one's a little trickier here. I've got an ethyl branch and 2 methyl branches. Oh, and notice on this one we got CH3 and then we got C3H or CH3. It's just written a little different. Sometimes you see this. Anyway. Okay, if I was to number it this way, here's my ethyl and here's my methyls. I'd have 1, 3, 4. I add the sum total of those up and I get 8. Now even though we name this alphabetically, we don't number it this way. We have to number it so that our branches get the lowest possible numbers, which would be this way, 1, 2, 3, and then 4. We add the sum total up there, we get 7 instead of 8. So the red is the correct way to number this, but we still name it alphabetically. So we don't do this. That's named alphabetically, but with incorrect numbering. Here's their proper name. 4-ethyl, 1,2-dimethylbenzene. So that one is incorrect. Okay, hopefully that makes sense. Let's move on. Now, benzene can be a branch instead of a parent. So take a look at this one. There I have a parent, and this benzene is a branch, and this is a branch. Now you might say, wait a minute, this has 6 carbons in it. Shouldn't this be the branch all the way around here like this and then on? Well, I can see an argument for that. In our course, we'll call this the parent and this the branch. So if the benzene is attached on a middle carbon to a chain, it's going to act as a branch. Anyway, now when benzene is a branch, we don't name it benzene, we name it phenol. So watch this. That's a branch. That's a branch. That's named methyl. This one should be named benzene, but it's named phenol. And now we can number this. We're going to go with lowest possible numbers again. So we're going to go 1, 2, 3, 4, 5. But still name it alphabetically. 3-methyl 2-phenyl pentane. Alright, and let's talk about this next one here. There's our parent. And just 1, 2, 3, 4, 5, 6 carbons that way, or 1, 2, 3, 4. So this branch is attached to carbon 3. 1, 2, 3 instead of carbon 4. Alright, let's name it 3-phenylhexane. Great. Let's talk about some physical properties. Benzene is a liquid at room temperature. It's because it boils at 80.1, so at 25 degrees Celsius. It hasn't boiled yet, it's a liquid. This is non-polar, therefore it is not soluble in water. And it's neither saturated nor unsaturated. Because of that double bond thing I talked about earlier, we just don't think of these as either saturated or unsaturated. It just doesn't even, we don't even count it in terms of saturation. Okay, in the early 19th and 20th centuries, benzene was used for many common applications. Notice it was a degreaser. Okay, it was used in aftershave. That's a bit of a problem because benzene causes cancer. So as soon as they found that out, they took it out of aftershave. Decaffeination of coffee. Alright, it was determined that it was a carcinogen, therefore today it has few applications other than industrial applications. It is a component of gasoline. With gasoline, it improves octane ratings, okay, and it also reduces this thing called engine knock. I used to have this 1991 Pontiac Sunbird. When I went up a hill, the engine kind of clunked, it knocked. Anyway, benzene can improve octane rating and it reduces engine knock. Now, methylbenzene is less carcinogenic, and so it's used in some applications today. Okay, that's it for aromatics.